Are you able to hear my sound? Are you able to hear my sound? Okay, I think you could hear my sound. Um, I'm going to take you guys through some basics of working model as instructed by Dr. Mbufo. Um, I think firstly you may have your PC so you could follow up. The system I wanted to use for this tutorial, just as I was broadcasting, um, I was told that drivers is now updated, so I had to fall back on a backup. So it will not be the best of experience, but just bear with me. And if you have any questions, you could drop that through the comment. Yeah. Okay. Is the view clear? As in the size of on your screen, is it clear? Is it okay? Okay, I think I have a positive response from one person, and that's enough. Um, Firstly, what I would have to do, the first thing we are doing is um, setting up the environment. You would, okay, if I go to file, for file, it's just like your normal Word document to save, to open, to close, or document, to import a design, to export a design you have done, to print the design you have done on the page. And remember, this 2D, not 3D, 2D only. Yes, for edit, you're copying, you're pasting, you're deleting, you're duplicating. It all has shortcuts available here that you could use. Um, you go to the world, for example, over here, gravity. If I click gravity, we have a mode here, vertical. So if I choose vertical, I could now type in my own gravitational acceleration. If I say no gravity, it means the effect on the bodies on this workspace would be zero gravity. When I say planetary gravitational force, it means I would have to enter um, the planetary gravitational force. Okay, so I keep it at vertical at 9.8 meters per second square. I think that should work. Okay, we go to view. Oh, okay, world. We have air resistance, we have force field, electrostatics, electrostatics. Um, we have run. Well, we're running some designs now, so you see the effect um, on it when you run. We design and then we run it using some forces and see how they display. You are going to do mechanism synthesis. So what it means is you design a system and then it's supposed to undergo a motion to achieve a particular aim. For example, the car wiper on your car, like um, it's actually run by a motor. While the motor is turning as a revolution, your car wiper does not turn through the same revolution. Your car wiper goes back and to and fro, like at a certain angle, not 360 just like the motor. So it's translated. The motion is translated to the wiper itself. That's what mechanism synthesis is all about. Yes. Let me see. Skip frames, tracking. I think while we're doing a demonstration, we'll change some of these things so that you see how it affects um, the motion on the workspace. Yeah. Um, let me see. Let me go to preferences. So, well, all of this we won't need it for the basics. Let me go to view. For view, I go to workspace. I think I can bring my ruler, that's by the side, and then I could bring the grid lines and then X and Y axis. And you realize that over here, the toolbars you're seeing here are all the standard. When I disable the standard, you see it's up here. So if you have installed your working model and then you don't have all of the things I have here, you would have to go, um, you go to view workspace and then you could edit it. You could, I think there's a simple one here. Play this stuff. We'll be using some of the commands in this area. So let's get to it. View, what else can we do over here? Which snap is mine. When I'm drawing any object now, you realize that um, let me just it's on, so let me just use it. For example, I'm drawing a square. You see, it snaps to the grid when I move here. Even though my pointer is not exactly on that intersection, it is snapping to the grid to help me draw a perfect square or design whatsoever. And mind you, if you're going to draw and then you wouldn't be using, for example, if I wish to pick a point just beside it, it's not advisable to turn my grid on, because if I turn the grid snap on, what it means is that it's going to pick it from the vertex instead of using the real position I'm choosing. So I think that's about that. You and then objects now, or when we have objects over there, you see it numbers and units. Okay, so SI radians. I think let's use SI units, but we use degrees instead of radians. You have you have slag, you have pounds. You could choose any you want. I would go by SI degrees, and yes, that's okay. I could go for more choices. Distance should be meters, mass kilogram times seconds, charge coulombs, rotation degrees, voltage, velocity, miles per hour, speed of light. Oh, I'll leave that to be what it is. Frequency should be in hertz. Energy joules. First leave this. I think that should be fine. Rotational velocity should be meters per minute. Velocity itself, I wonder why. Let's see when we analyze. Let's see which units they use for us. Okay. Let me see. Go back to view. You could change the background color of your. I'll leave it white. You could change it over here. See, then when you create a reference frame, you could delete it from here. Well, all of these are not so important. As a, oh, I'm even drawing something. Escape. Escape. Delete. Okay. Now let's start. When we get started, I would use some of these tools, and then you would see how they are used. You're not going to cover everything because I'm not instructed to go through everything. Most of it you are going to kind of learn on your own, but I'm supposed to do introduction so that you could at least um, get an idea of the capabilities of the app. I think the display image I put uh, for the live is an engine. So what it actually means is that you could use working model to design a 2D version of an engine block. You see the motion of the piston going up and down and all of those stuff. It's possible, but that's very advanced compared to what we are going to do here. But if you understand the basics, yes, you could play around it and then get to that point. That's fine. Okay. So first we go by the object over here. You have a circle. You could just draw a circle. Center. You expand. And then you have it there. Um, I have a square. I point. I draw. I drag. I have a square there. Don't worry for that. We are just this polygon. Click on your polygon. You draw. You draw anything you wish to do. Uh, okay, so I can end it here. It becomes a solid. And then there's a curved polygon. So this is also a polygon, but it is curved. So I could draw something like this. Turns into a curve, multiple points, and then it should be fine. So I click escape to close it. So if you're wondering how I close that, I used escape. Okay. And then for a rectangle, you use this. I could easily draw a rectangle. Okay, that's fine. Now let's just do something. Let's just run. Remember, we used acceleration due to gravity. We used 9 meters per second square when we're setting up the environment. So if I run this, everything falls. I could stop, reset. If I run it, everything falls down. Yeah, due to gravity. So this is an environment. This is an environment you could illustrate forces acting on bodies and all those kind of things. Yes, and in essence, mechanical mechanism synthesis. Let me see. Okay, the last one we have in a corner here is the anchor. And I think one thing you should notice is that anytime I point something here, when you watch the status bar over here, down here, when you watch the status bar, you would realize that it states what the tool does. So let me go up there again. Anchor, it states that prevents the body it is attached to from moving. So let me use the anchor on, let's say, this body. Yes. So now let me run again. Run. So you realize that this body is not moving, but this one's moved, and I think this is stopping the other ones from going down. So I can still stop it and reset. Let me run it again. Yes. So let me stop that and reset. And yes, um, I think we were editing something here. Accuracy. If you go to accuracy and then we change this, let's say we change it to 0.0125. Okay. If I run this, you realize that it is. No, did I save that? Let me see. Accuracy 0.0. Okay. Okay. If I run this, this is extremely slow. It's too slow. Let me reset that. Well, accuracy. Okay. This 0 here. 0. Okay. Run this. Yes. So we could when you increase when you decrease the accuracy, it happens very fast. I don't know whether I've interchanged that. But well, if you change that figure, what it does is that it shows you the motion in a slower manner. If you reduce that figure, it shows you the motion in a slower manner. So, well, we do some other designs, and you realize the importance of something a feature like that. So I think we understand how to use the tools, these six tools here. If there are any questions, the person can put it in the comment section if you have. So let me wait for about 2 minutes. If there are any questions, the person can you can just drop it in the comment section. Yeah. Okay, I think I've initiated a Zoom. I think it is looking better now, or I could still make it 150. I don't know. I think this should be okay. Um, delete this and then start all over a new file. I my workspace. I set my ruler, my grid lines. Close. Okay. Now we are going to the we have point element, we have the square point element, we have the slot. Yeah. So I think let me draw some bodies that we experiment with them. So this is a square. Let me put a rectangle here. Okay. So with this to the this is a point element. Join another point to create a pin joint. So this point element is used to create this joint. So let's say this is a point on the body. You could use this to create a pin joint if you put this onto this point. I don't know whether it is making a little bit sense. Well, let's use the methods of joining and then we see how that works. So with this pin joint, joins two bodies with a hinge. Let's try that. Let me drag this close to this. I would put okay. So I'll use a pin joint to join this and this. Now, if I run this, everything falls, right? So I wouldn't do that. I would use the anchor to hold this in place. If I use the anchor to hold this in place, remember this pin joint is acting as a hinge between this body, the square, and the rectangle. So if I run, yeah. So that is the effect. I give you 2 minutes. You could practice that on your computer. I'll be back shortly. Okay, I think you should you should be able to do something like that by now. I'll stop this and reset, and then we get to the next two. This is rigid joint. It locks two bodies together. Rigid joint. It locks two bodies together. So let me just create a circle here, and then I draw my circle. Okay. So what it means is if I bring the circle here and I put the rigid joint here, I'm expecting it to lock the circle and the rectangle together. So let's run. Yes. So it allows just that. It locks the circle and the rectangle together. Okay. Let me stop that and reset. This is a slot joint. A slot joint. How do I explain this? Let me create a design. Put a slot joint here. So I put a slot joint here. If I put a slot joint here, let me pin this guy. So if I use this pin, what it actually means, I'm pinning this guy to the um, background. So if I run off, apparently my slot didn't work. Let me reset that. I need a pin on this body. Yes. Now I need to join this. Oh, sorry, this into this. Wait, let me just delete this guy. Delete this. In the slot. In the slot here. No, no, no. And the slot here. Okay. Let me run to see. Oh, oh, stop. Okay, let me pin this. Let me see whether it moves. Oh, this is actually preventing. This is actually preventing the motion of this problem. Stop this. Reset. We need a sliding motion. How do I? Let me give it a force. Let me give it a force in this direction. Let me run to see. Oh, yeah. So I don't know if you know a slot. A slot is like it gives you a linear path. You can just go anywhere you want. You don't have to be on that guided path. That's how the slot works. So I think I applied. You see, let me put a body here. Let me put another body here. Okay, let me pin that guy. Let me use the anchor. If I run this now, ah, okay. So you realize that stop. Let me run again. Oh, let me reset. Let me run. Stop. Okay, reset. Now I'm going to add a feature. I'll select the whole thing, and then um, let me see measure. No, I'm going to use window. I'll go to window. I'll go to properties, and then I'm going to put a elasticity to 0, right? So okay, now if I run, immediately hits it. There is no all energy is just absorbed and there's no bouncing. You remember last semester, I think one of the your questions, a body was coming in this direction, the other one was coming in the other direction, and then they collided, and you were asked to find the velocity afterwards. We could actually do solve that question using working model. We could just make this body roll. Or was it? No, it wasn't angular velocity. So all we could do is we give it an initial velocity is going this way, and then we give the second body another velocity going this way, and then we would actually find the answer. So let me change the coefficient of, yes. So let me select everything, and then I'm going to change properties to, let me change to 1. So no energy is absorbed. If I run this now, you realize that once it hits, once this hits the square body, it goes back to where it came from. Ah, as simple as that. Yes. So you could also take some time to play around with a little bit. I'll be back in 2 minutes. Okay. Well, I'm just seeing that some people are mentioning that my pointer is very small. Wow. So let me do something about that. Oh, is it fine now? Because I think I've increased my My screen zoom to 200%. So is it fine now? Okay, well, let me continue from where I stopped. I don't know what I should delete all of this and then do something else. Um, so this is slot, this keyed slot, rigid. Okay, I think we have done rigid joint. We have done a pin joint, curved slot. I think we draw a curve and then put the slot on. Closed curve slot. I haven't tried something like that myself. Let's give it a try. Mm. I'm not supposed to treat something like that, but I'm curious. Let's see how it goes. Okay, I have a curved slot. It's good. Oh well. Now I think I need a body that's supposed to move on that. So I draw a body and wait. Oh, wait. So let me put a pin here. No, wait. Okay, let me delete that. Let me put this here. Put this here. I'll split it. Move it to this point. Move this to this point, and then join it. I hope this works. I hope this works. Wait, let me anchor this first. So anchor. Run and see. Hopefully. Oh, nothing. 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 Doesn't work. Well, you could play around it. On this. Oh, this is actually working. Wait, I now get it. Easy. I use this rigid joint, and the rigid joint has joined my circle to the square to the platform. So now the small circle must move with my square. I think that's what the problem was. That's what the problem was. So okay, I know what to do. Let me delete this. I'll delete this too. I'll delete this too. Let me not anchor this. Let me delete that. Now I would draw first. No, let me delete that. I'll draw a slender rectangle and then add lines to this and this. Okay, and then I would add a motor. Yeah, so this is a motor. Apply stocks between two bodies. I would add a motor here. Let me see how that goes. Am I supposed to count something? No. Let me run. No, there's something wrong. Change this joint. To a pin joint. Let me see if this works. Oh, that's sad. Let me see. What am I not getting right? Let me get it here. Let me just try this and see. This alone is not running in a circle. I'm wondering why. Did it? Let me run this. Oof. What? I'm not able to do the. I'm not able to do the revolute. So remove on this. It's not part of what I'm supposed to. Wait. Think I'm making a mistake. Let me see. Alright. We may get it right. Minute. If I create this and I add a slot from this point, yeah, and then I add a body this way, and then I add a slot, a keyed slot joint to the center of this. Off. I was expecting this to be. Wait, you just have setting this to vertical. No, if I run this, everything falls. No, stop. You see this. Guys, a minute. Yeah. So that my catch guy no say on area on problem show. My catch guy no say. So my channel is no. Wo Papa no man no number. Papa no. Papa no. Papa no ma wo brana on no family. Okay. Okay. Okay, I think yeah, I'm back here. Let me see. If I run this now, oh, I think there's a pin joint here that's not supposed to be here. Let me stop this. Reset. Think this pin, delete. Think number two now, right? Yes. Let's see. That is interesting. Stop. Reset. don't seem to get the slot right. I don't know. Well, if I figure it out, I'll take you guys to it. I think the next thing, I think, let me look at what I'm supposed to cover. Yes, motors, actuators, and springs. So I'll take you through that, and then I think it should be done by then. Let me delete all of this. Delete. Okay, so let me do the spring first. I'll do the spring first. I have this here, and I think it's this way. I'll anchor this. Then I have a circle here. I'm just building something like a pendulum. And then I have a spring. Yeah, this is a spring. So from here to this point, I can move this up. Okay. So now I can run this. Ah, yes. And I think this the spring is working. Yeah, it's going in all directions. That's bad. Oh, I'll show you something when we get to actuators. Okay, let me stop that and reset. For the spring, I could change the length. I could change the the force, the constant K. Um, you could also change the setting. You could make it active when the force is greater than a particular value. There's so much in this app. You'd have to take time to learn a lot about it. If you're able to understand this app, for a lot of the calculations you'll be doing in this course, you could personally just go back to your room and then you design your systems and then you understand it, because you could even plot a graph from what we are doing now. I'll do that as the last part of the session. Yes. So I mean, and I could actually change the mass of this. You see, I could change the mass of this. Let me see. If I change this to 10.785 kg. Now let me just close that. So now if I run, it has spoiled the spring. You realize that the force you realize that the force exerted by the body on the spring is too high to the extent that the spring is now spoiled. As you can see, I don't know whether you realize it. Reset. If I run it, it's gone. Easy. But at first, when the mass of this ball was lower, the spring was tossing the mass anyhow. If I run this now, oh, I think that did not save. Reset. Let me change this. This is saved. Then what is not saved? Let me see. The spring. Okay. So if I run that, yeah. Wait, let me change the figure again and let's see. Okay, well, this is running. Let me change the mass of this ball again to 10. Let's see whether it changes anything. So if I run this, yes, you realize that the mass is heavier, so it pulls it more. If I increase that again, I reset and I increase the mass. What's about if I make it 100? I'm sure that should be able to spoil the spring. Around that, it's gone. It's gone. It's gone. It's gone. Yeah, so it has damaged our spring. Well, apparently it's even moving up and down. How far did it go? Interesting. Okay, I think that was still not high enough for it. Let me increase it and see. What are it even bounce at all? Let me stop that. Reset. I increase this again. 1,000. Where is it at? 10,000. Right? PPP. Is it still bouncing? No, I don't see it to be bouncing. You could practice at your end and give me your feedback, your results. Is it still bouncing? Because at my end, I don't think it's still bouncing. I don't think it's still bouncing. Let me set this. Okay, so I think that is it for springs. What do I do next? Let me do actuator. Actuator. Do this. Oh, sorry. Okay, so this is an actuator. I'm going to put a body on this actuator. Okay, so now I don't know the mass of this body. I don't know the force this actuator can handle. Let me just run and see which one overpowers which one. Oh, wait, stop, reset. How am I able to get this? Wait, fine. Let me see. I think colliding bodies. There's a setting. No. Oh, wait. This should be. This is acting. Can you see that? Come on a second and see. Stop. Reset. This is. Interesting. Mm, Back to the console. Off. Wrong direction. Wrong direction. Um, wrong direction. Delete that. Okay. I think this joins it. Let me run and see. Okay. Stop. Reset. Okay. Now let's do something. I think this is not vertical enough. Let me rotate this. Okay. Now let me. let me show the center of mass of this body. Okay, well, the mass of this body, let's make it 10 kg, 10 kg, and then this 10 kg mass, and the force from this is 1 Newton. So you realize that the 10 kg times 9.8 should be about 98. The force from the block should be about 98 coming down onto this 1 Newton. So Baum is the body should overcome. Yes, yes. So the body overcome the actuator. Let me change the force here to, let's say, 100. 100 is bigger than 98. 100. Let's see what happens if I run this. Yeah, you realize that the actuator is now pushing the body out. Let me stop that, reset and run so you see. And I think one of the reasons why the body is rotating is that I did not place a point at the center of this body. You should have pushed it up vertically. Yes, but I think that's why I did not put it at the center. So that's a problem. So if I run that again, still pushing it buff. So let me see. Well, that is it for actuators. So what it means is that if you double click on this circle now, you could change the mass of the circle. It's taking it as a body. You could change the static friction, kinetic friction, elasticity, the material. You could even change the material: steel, ice, wood, plastic, clay, rubber, rock. You could change a lot of things. So this is a very, very powerful tool. And what you have, the setup I sent to you. Oh, hello guys. A minute. I'll get back to you. Okay. Yes, I'm back here. And yes, as I was saying, the material. You could change it to anything you want. Once you change the material, the density will change to, for example, if I change to ice, density of ice is 0.9. You see all of that. See all the information changing. If I change to steel, you see the density has changed. So there's so much you could do with this application that, uh, well, I don't know. You could do a lot, especially for your final year design project. You can, for example, let's say aerospace, you are building a drone. Yes, you could, how do I call it? You have the force effect here. We have torque. You could do your own design. You put this here. If this is this size, this is this size made of this material, and it is producing, the motor is producing an upward force of this. If I put this payload on it, how is it going to behave? If I put the payload at this position, how is it going to behave? Yes, you could do a lot of analysis from here, and trust me, if you have a simulation from here and you display to Oh, that second year. Sorry, second year design project. Yeah, so something like that. If you're able to do, I'm talking as though I'm talking to a final year student. So if you're able to do something with this application and then show a simulation to the lecturers, well, that should be impressive. That should earn you some scores and marks. And well, the experience itself is good. It's worth it. Let me demonstrate the motto, and I think from the list I have, I think that is it. So let me work on a design for the motto, and then we see how it goes. Let me take off this activator. Or if I can squeeze it in, it should okay. Okay. So now I have this design. And then I have my. I'm going to turn off the grids now so that I could draw whatever I want. I'm going to draw this. I'm going to draw a four-bar linkage. We are going to study that when you start the course. You start the course. Okay. And you could actually change the. Let me see. If you go to window appearance, you could change the color of this. So you could change the color. You could track the center of mass. You could show the center of mass. You could do a lot with this. Trust me. You do a lot with it. So now this is the center of mass. Let me change the color of this too. Appearance. Which is great. Show center of mass. Okay. Now let me see. We need to pin this guy and this guy. Joint. And then need to pin this guy to a pin joint. Let me give the first one a minute. Let me see how that works. If I give this point a button, if I run this, how does it behave? Apparently, you know what happens? What happens? I set oh, I set tracking to be on. That's the error I made. That's why my appearance track. I think I tried to connect for one of this. Yes, I chose track outline. So hey, and I even chose track set of bus. Because let me see what I did for this. I just track outline. Okay. So I gave you that is it. If I run again, it's no longer tracking. Stop reset. Now how do I clear this? My workspace I set one new. Okay. So let me do the four bar linkage here. We are going to do some. we're going to extract some data from there. So I wouldn't. So you could easily do Control D, duplicate. So it makes everything simple. Hey, I go to exercise. So let me see. Let me make this. So you're going to learn the rocker, the oh, I've forgotten. I've even forgotten most of them. You are going to get the bass, get the rocker, and other. There are four. The rotor is this guy close to the motor. Let's see. Okay, now I'm putting my motor here. Let me change appearance of this again. Maybe to track the outline. Which is black. Choose yellow. No, there's no yellow. I'll run with that way. No, I think I still have track of yes. Okay, so now I have a pin joint here. Pin this and this. Where's my pin joint? I pin this and this. Pin this and this. So now I run. Yes, remember it's a pin joint, so I expected it to be that way. Yes, so now one last step. We said so actually in the course you're going to design this, you would even add how they call it. You're going to add calculation. You're going to do calculations based on your calculations. You would know the length of each of these bars. So let me see. I'll pin this here. Where's my pin? So I give a pin right here. Oh, now run this. So now this is a car wiper system. Look at it clearly. Oh, I should trace. You see the black? You see it's having just this motion like your car wiper. Uh, uh, but the motion is actually from this motor. So this is mechanism synthesis. And this is what you're going to do in the course. So you would have something like four boxes, and then you're supposed to make the body. How do I call it? I remember in the exams there was a question like that. You're going to do construction to find how the body would be moved from one point to the other without touching the table, but the motion is going to be generated from a motor. Well, when you get into the course, you would realize what I mean. Okay, let me stop this. Let me reset. Let me just appearance. Let me trace. Let me track the center of mass. So let me run that. So you see the black section there. So that's the area the wiper is covering. If you want it, if you want it to cover a larger area, it means the dimension of each of these linkages will change. And that's a calculation you are going to learn in the MA264 course. So it will be exciting, but not too easy. Let me see which other fun thing we can play with that. We could, uh, we could check center. Now let me show you a graph. Let me just check a graph of the motion of this, a position of this. So window. Oh, I can measure PVA, position velocity acceleration. So if I start now, so it is showing me the position, the velocity, and then the acceleration of this rectangle. And you could actually even get a graph out of that. Let me select this guy, measure. No, let me a rotation graph. Let me measure position graph. So now position. Let me run that. If I run that, it goes up, it comes down, it goes up again, it comes down, goes up. So there's so much you could do at this end. Well, if you understand it, it will be more to your benefit as an engineer. It's very, very important to know how to use this. Yeah, these are features you may not easily be able to implement in something like SolidWorks. If you want to run such a simulation in SolidWorks using 3D, it will take more resources in terms of your graphics, memory, your RAM, your CPU, and all that. Well, this is done in 2D, so and it's lightweight. And let me tell you this: the setup you have, don't lose it because it's no longer available online. I think MathWorks has been able to purchase. Is it a company or they have been able to get the app? So now it is you can only get paid subscriptions. Uh, Free is no longer available. Demo, you don't get it. I don't know if you tried to download from online, you won't get it. So keep it very, very well. And I think it will be very, very useful if you want to design the systems. If you have any questions, you can put it down there in the comment section. In about 3 minutes, no questions, we could just end it there. I think that should be fine. Okay, so I'm waiting. You are saying you would use crack. What I'm saying is that it's not even available for you to download before you crack it. Do you understand what I mean? Yes. It's not even available for you to download. So that's fine. Now that you have it, you could keep that. So I think this is what I was supposed to take you guys through. I was thinking it wouldn't be very effective if I do that in a class. Yes. So I think this works, and yeah, I've learned something out. See you guys in class next week. Okay then. Bye.